Now, what can affect the power of a test? Well, both alpha is what? The level of significance, and n, the sample size, can affect the power of a test. And how? Let's look at the example, okay? Suppose I fix my alpha as what? No, suppose we know this, right? Alpha is 5% and n is 100. A level alpha equal to 5% test is that we reject H naught when x bar is greater equal to 0.598 or x bar is less equal to 0.402. As I mentioned many times already, this is from YouTube video, approach 1. Is that okay? So when we choose alpha equal to 5% and sample size is 100, this is our 5% what? Level alpha 5% test. That is, we're going to reject H naught if x bar is greater equal to 0.598 or x bar is less equal to 0.402. And power 0.4 in this case what? 51.6. Okay? It's 51.6%. Now if I change from 5% to 10% and sample size stays the same, n equal to 100. Let's see what happened to the power. Okay? Then a level alpha equal to 10% test. I change alpha from 5% to 10%. I make alpha bigger, okay? And sample size stay the same. What is my level alpha test? I'm going to reject H naught if x bar is greater equal to C1 or x bar less equal to C2. The following calculation procedure is for us to determine what? These two numbers. Okay, let's recall what you learned from what? Hypothesis testing, approach 1, okay? X bar follow normal distribution because n equal to 100 is large enough. By central limit 0, x bar follow approximately normal. Okay? If I use upper 2.5%, lower 2.5%, 2.5% plus 2.5% gives what? Alpha equal to 5%. Okay? So in that case, we get what? We get this number here is what? 0.598. This number here is what? 0.402. But I change to 10%. So upper tail, lower tail, I take what? Both 5% off. From 5% to 10%. I take upper 5% off, I take lower 5% off. So these 2 points should move close to the center. Can you see that? That means you have a bigger one, region of rejection. Okay? Now we're going to determine how big you call too big, how small you call too small. Okay? This is C1, this is C2. Let me write this down. Okay? This one is C1, and this one is C2. Okay? C1 and C2. C1 and C2. Okay? So I want to determine C1 and C2. And how can I determine C1 and C2? Well, I need to standardize X bar. X bar minus expected value of X bar divided by square root of variance X bar. Okay? Convert to Z-score. But EX bar is what? Is pi. Under H naught is true, pi is what? A fail coin is 50%, 1/2. Okay? And divided by square root of variance X bar. Variance X bar is what? Huh? Do you still remember? It's square root of what? Pi times 1 minus pi over n. Remember that? Pi is 1/2 times 1 minus pi is also 1/2 divided by n is 100. So you simplify it, you get 1 over 20. Okay? So let's standardize this. Okay? C1 minus 1/2 over 1 over 20. And this is C2 minus 1/2 over 1 over 20. But remember, we no longer use what? Alpha equal to 5%, right? 2.5%, 2.5%, add up to 5%. Now we change to 10%, right? So this one is 5%, this one is lower 5%. Upper tail 5%, lower tail 5%. In this case, it's no longer 1.96, it's what? 1.645, okay? If you use the table. You will find this is not 1.96 anymore. It's 1.645. This is minus 1. It's minus what? Minus 1.645. And then we solve for what? C1 and C2, okay? We solve for C1 and C2. And let's see, what's C1 and C2? We solve for C1 and C2. C1 minus 1/2 divided by 1/20 is 1.645. We find C1 is what? Is 0.45825. And what's C2? C2 is 0.41775. Compared to the one we use 5%, C1 is 0.598, C2 is what? 0.402. Huh? These two numbers is more close to what? To the center. Can you see that? And therefore the regional rejection become bigger. Okay? So let's calculate here again. Power equal to 0.4 is 1 minus what? Beta, when pi is 0.4. And why you don't reject H0? Because it's close to what? The center. From 0.41775, this is 0.41775 to 0.58225, okay? In this area. And you standardize it, you find what? You find power at 0.4 is what? 0.6406. It's about 64%. And this is bigger than what? Huh? Alpha equal to 5%, power is only 51.6%. Okay? Does that make sense? Huh? Of course it makes sense, right? When you use what? When you use bigger alpha. Alpha is what? Probability of making type 1 error. If you allow yourself to make a bigger type 1 error, that means you're going to have the same data set. You are less likely to make what? Type 2 error. Is that clear? If you are less likely to make type 2 error, 1 minus type 2 error is power. Of course, power will become what? Bigger. Okay? Let me try one more time. If you increase your alpha from 5% to 10%, that means you allow yourself to make what? Higher what? Type 1 error. So type 2 error will become smaller. If type 2 error becomes smaller, then 1 minus will become what? Bigger. Power will become bigger. Is that clear? Okay?